Welcome to How To, a Quality Digest series for quality control and quality assurance specialists who need quick instruction on how to get something done. This episode is sponsored by Mitutoyo. And now Craig Howell of CPM Labs is going to show us how to calibrate a digital micrometer.
Hi, this is we're going to be calibrating Mitutoyo's 5 millionth resolution digital micrometer. Fantastic tool. So anyway, to calibrate a micrometer, the very first thing we would do is we would clean off the anvil and spindle using alcohol. We check for burrs. If there were burrs, we'd remove them first because burrs will ruin your equipment. So the first thing we would check would be with an optical flat. We would check the flatness of the anvil, check the flatness of the spindle, then we would close it down together, and this is an optical parallel as well, so both sides are parallel. We would check and make sure that the surfaces are parallel with each other.
And I should mention that that we're going to do a video on this later. We need actually a microscope, kind of a microscope camera that can get in to see the bands, the light bands on how to do this. So we'll have a separate video for that. Keep your eyes open.
But I should go a little further with that. You're measuring light bands with the optical flat, and you're measuring the curvature of them, not the quantity of them for flatness. Usually you set it up with enough pressure to give it 3 to 4 bands, and you're measuring the curvature from the start of the band to the end, and each band that passes over is 12 millionths out of flat.
Okay.
So you can count the curvature and know if you're 12, 24, 36. Typical OD mics, the old standard federal tolerance was 50 millionths on each.
Okay. And you would do this first because if you're out of flatness or out of parallel, it doesn't make sense to go any further.
It would be a waste of time. Okay. So the first thing you would do after you've cleaned and deburred would be check the flatness of each anvil and spindle, then the parallelism. These are critical steps. A lot of people think if they just have a set of gauge blocks in their shop, they can calibrate a micrometer. That's part of the process, but it's not the full scope. The full scope involves also flatness, also parallelism, that sort of thing. So the gauge blocks we're going to use are ceramic gauge blocks, and they're set up specifically for calibrating a micrometer. And I'll get to that in just a minute. Mitutoyo provides a nice little cleaning cloth with their micrometers because any particulate, any sort of thing in between is going to show up at 5 millionths resolution. First thing we'll do is we'll zero it. Recheck. Sometimes under the lights, I don't expect this to hold up very perfect. You know, we're going to see a digit or two.
Yeah.
But the gauge blocks are set. Let me show you the gauge blocks because they are set to very specific sizes. The first is 105, the next is 210. What's happening is each time it's moving the spindle out 100, 200, 300, 400, 500, but not at the same barrel rotation. Okay. If there were a parallelism problem and you only checked it at 100, 200, 300, you never see that parallelism.
Because the barrel
at the
rotates,
same place.
Would end up at the same place each time.
Where 105 offsets it a little bit, 210 a little further, 315 a little further.
Okay.
So these are very specialized. You can ring up gauge blocks of your own to do this, but here's a set from Mitutoyo. Comes with all the documentation you need. This entire set will calibrate a micrometer quite well. Okay. Let's go back to that and show how it's done. So we've zeroed it. One of the first things we will do is I'll check the 105 thousandths. Careful not to drop these gauge blocks.
Yeah. What happens if you do drop a ceramic gauge block?
It's one of the beauties of ceramic gauge blocks. People are afraid, they worry, oh, they'll shatter like glass. I can't use these because we might drop them. They won't typically break. They're very, very durable. So under the lights, we are showing a 3/10 difference, which normally we would write down each step that is done. Each time we took a measurement, we'd write down the step of what we got on it. Now the beauty of these, they have a digital output.
Right.
So you can buy the foot switch and the cord. You can output that right to your computer and take your measurements without ever taking your hands off. You just hit the foot switch, lock in your measurement. Now we check it at the 210. We would do this all the way throughout the whole range from 0 to 1 inch. I'll just show a couple different checkpoints. Under the heat lamps here, these blocks have heated up some.
Right.
So this is more representational than literal. But we would do that through the whole set. Okay. And after that, if it passed flatness, parallelism, and this is called lead error.
Okay.
That would be calibration of an OD mic.
I wanted to show something just because what you were saying when we look at this. So here's the arrow on the barrel, right? And so
Right.
normally one full rotation is how,
It would stay there each time.
and a full rotation represents how much?
25 thousandths.
25
So
thousandths.
4 rotations is 100 thousandths.
Okay.
But the first one's offset a little bit here, the arrow's down.
Okay.
The next one, the arrow's a little further. The next one, besides moving out.
Okay,
it's
so
a
that's
little
what you
further.
were talking about. If you were to do even increments of 25 thousandths, you would the arrow would always end up, and the anvil and spindle would
same
always end up the
place.
same place every time. Okay, gotcha.
So that's how you would calibrate a 1-inch OD micrometer.
Okay. Now, what if you had a bigger micrometer? Suppose you had like a 2-inch.
Glad you asked that. That's a good point. This
Glad
is
you
a
set me up for that.
This is a 2-inch steel gauge block.
Okay.
And that is a question we're asked quite often. Can you ring ceramic to steel? The answer is yes. And the coefficients of expansion, the amount that these expand to different heat ranges, is pretty close. Ceramic
Okay.
is a lot closer to steel than carbide is. So you can ring these to the point where you can actually lift the gauge block just by the ringing force alone.
Wow.
So these are rung together. You would use these, each one, you start off with the low end. This is a 2-inch, for a 2-inch, 2 to 3-inch OD mic. You'd ring one on, check it, ring the next one on, check
Oh,
it.
okay, okay. So
You'd
if you had a 3-inch micrometer, you would put
start with a 3-inch gauge
You'd start
block.
a 2-inch gauge block and just keep adding the set to it. Okay,
Correct.
Gotcha.
And in between ringing, by the way, you'd want to pause a little bit. The heat from just ringing will affect it after a while.
Okay.
So when we're doing very critical applications, we'll ring the block and stop for 10 or 15 minutes, let everything settle down.
Okay.
So that's how you would calibrate a micrometer with these. But you can do more than just micrometers. These are specifically set up for micrometers, but they are also a gauge block set that goes from 0 to 1 inch. We could even do a quick check on a Digimatic height gauge with these, just more of a sandy check than anything else. We'll zero it out. We're zeroed. You could check it, especially if it's near the dimension. If you're using other gauge blocks, you can get right down to the dimension you're after. And we got a little expansion from the heat. We're showing 2/10 high on the 400, but you can check it throughout its range using these gauge blocks.
Now, you're calling this a check rather than a calibration. Why is that?
Correct. We have specialized instruments for indicators that move one direction and they move in the opposite direction for hysteresis, which is more or less like a backlash.
Okay.
So you want to be going the same direction for repeatability, but you could do this right up through the range.
So this is kind of a quick check just to make sure that
Everything is going well.
right.
And then right up to the 1 inch, and you really are checking this out in a number of different places. So you can see how is your indicator responding in case there was a question about fixturing or burrs or whatever the question was.
Okay.
So that's how you could use it for an indicator.
Okay. Well, thanks, Craig, and thanks to Mitutoyo for supplying the equipment for this. That was the high accuracy digital micrometer and the Digimatic indicator. They also are the sponsor of the show, so thank you guys for doing that. And thank you all for joining us, and we will see you at the next How To. So long. As the world's largest provider of measurement and inspection solutions, Mitutoyo America Corporation offers a complete selection of machines, sensors, systems, and services with a line encompassing CMMs, vision, form, precision tools and instruments, and metrology data management software. Mitutoyo's nationwide network of metrology centers provides application, calibration, service, repair, and educational programs.